Okay, good morning, all of you. So today I'm going to start Docker and Jenkins. Regarding Jenkins, few topics are pending. The Jenkins backup and restore, version upgradations, okay, and master and slave, okay. A few things. Majorly we cover few things. That is enough for only one class. But I will cover after complete Docker and Kubernetes. I will give you some break in the Jenkins, okay. So today we are going to start Docker. What is Docker and installation process? If we have a time, we can run sample commands also. Okay. So guys, we have a class tomorrow also. Completely your wish. Okay. If you are logging or not. But one thing I'm very clear. If you miss one class coming month, no one will help you. Even mentors also will not help you. Mentors also will not explain process from the scratch, right? Maybe they can understand where you start. If you ask what is this again, what is this, what is, they can also do it. They can't do it. Understand? So this 1 month is very important. If you miss 1-2 classes, I can't do anything. And one thing I can say, yesterday just I verified with the management. Our strength is 120, but joining here only 80. What about 40 members? There depends on only recordings. That is not a good practice. Okay, you can take recordings. Are you paid or your depends on the recordings? But even though try to attend the classes, whoever taking the recordings. Recordings is different, live is different. Recordings, guys, you will not get interest. If you see one recording, next we can put a pending for 3-4 recordings. And again, you can start one recording. So you are not in the correct flow if you flow recordings. Recordings is only help to you if you're 90% fine in this class. Next 10% may be help for to the revise the things only, not for depends on the recording. If the depends on the recording, everyone can take the recordings from the back door, something doors, right? So many doors we have: back door, front door, top doors. You can take it, but that is not helpful for you. Once again, I'm saying, but whoever follow my class from the day 0 to day 95 or day 100, mark my words, at least maybe getting a job may be late, but 100% get a job. 100% get a job. And not only as a fresher, it's a 4 years experience job you will get it. 4 years experience means you can easily get 18 lakhs per year. So that do hard work for only 4 months. I'm not asking 1 year, right? Only 4 months. I'm going to cover so many topics here, advanced topics also. If you're interested, I will cover. See, if you're not present means I will jump to other actual classes. See, today I have covered Helm to your seniors. Helm is not in our syllabus. Helm charts, Helm files. We are using nowadays in all organizations who are using Kubernetes. I covered. So if you are showing any interest, I will go little depth. If you are not getting any interest from you means definitely I will complete the course as per the 90 days or 85 days. No need to spend for 90 days, right? Anyway, it's up to you guys. If you need a job, you follow. Otherwise, you can attend on off like switch. Completely your wish. But definitely whoever attend my classes, definitely they will get a job. Maybe sometimes due to some recession, it will maybe late only. Okay, but definitely get a job. I have started my career in Naresh 1 year back only. Previously, I used to give other institutes. The first batch students, I have started here only 30 members. Okay, 20 members got a job. Maybe some late only. 20 members got a job already. So understand it. Even not only get a job, they are easily handle the tasks. 3 years, 2 years experience they put on event, 3-4 years, they easily handle the tasks also. So that depends on your interest only. It will. Just 4 months. I'm not asking your time for 1 year only. Okay. Okay, guys. Let's understand what is Docker first. So in last class lab, we have discussed to deploy our application directly into the server. Okay. Okay. So understand the requirement. There is a project. If Uber team hand over project to something, project to any company, Wipro. So both are my companies. That's what I'm taking. So Uber team hand over project to Wipro. So what Wipro has to do, implement the project, what Uber is giving. Now Uber is saying that in this project, you need to deploy, you need to develop the project as a microservices basis. I mean, my application always up and running. You can take a Flipkart, Amazon, or whatever it is examples. So you need to develop the application in microservice, in microservices process. Here, two things we can understand. The advantage of the microservices is we can split into the different application of your main application. Is this clear? So we can split into split into multiple applications. Okay. Okay. So maybe if there is an impact, that respect to application may be impact if something is there. Okay, this is okay. This is okay. We are very clear. So now the client is saying, so we need to develop this project with less budget, with minimal budget, or okay, minimal budget. So in that case, minimal budget means we need to reduce the infrastructure cost. Okay, reduce the infrastructure cost. We should not deploy multiple servers and something all. So what we can do? So we have an option Docker. We have an option Docker. So what Docker is saying? So we can, what Docker does, we can install Docker on your EC2 server. For example, your application is 50 applications. Just assume it. Finally, 5 applications is coming from this project. We have implemented 50 applications. Okay, 50 application. So if there is no Docker, what you need to do, guys? You need to deploy, create a one server. One application only. We need to create one more server, second application. Like that, how many servers we need to create? 50 servers for only 50 applications. What about high availability? We need to maintain standby application. Maybe this application will not sufficient for only one server. We need to create one more server for this application. Understand what I'm trying to say? So here we can draw the architecture. So this is, let's assume VPC. Okay, let's assume VPC. So if you create the servers 1, 2, like that 50, right? Or 100 to provide high availability. So we need to create like this servers. Okay. Now you understand here. If you create EC2 here and deploy one application like this, if you can create EC2 instance and deploy applications. So maybe in this 50 applications, for example, two application is one is for uh, fashion. Okay. One is for electronics, etc. Like 50. So this is fashion one. This is server EC2 instance. To provide high availability, one more fashion one and EC2. So one more fashion. Depends on the traffic, it will increase the nodes, right? How to increase the servers? Very good. Auto scaling. So your auto scaling keep on increasing the load whenever load is there, whenever traffic is more, auto scaling group will add new servers. Is this clear? This today class understanding is very important to enter Docker and Kubernetes. Whenever traffic is more, ASG will add new servers. Let's example. Same electronics also. So electronics also added like this way. So now to give access to these servers, how to give it? Load balance, right? So we are going to configure ELB. We need to configure ELB. We can give access to your all servers. Clear? It is go to your public platform. But now, but now, we need to understand here one thing. This ELB, if it is not path-based ELB, we need to create each application one ELB. If it is a not path-based ELB, so we need to create 50 application for 50 applications. How many load balancers? 50 load balancers need to create. If it is a path base, yeah. If it is a path base, one ELB. So, okay, that is different story. So path base means, so ELB / electronics, ELB / fashion, like that it will work. Example, path base. Okay. So here we need to understand ELB is a main. They can access the public by using ELB enter applications first by accessing ELB URL. Okay, by using ELB, we can access. If they give path ELB / electronics, it will go to ELB electronics. If I give ELB, for example, yeah, ELB fashion, it will go to fashion path. ELB sports something, whatever applications, 50 application, it will go to sports. So again, after open this main ELB, they are able to see everything like Flipkart. Like Flipkart, if I go here, I'm able to see everything, right? If I search mobile, my path will be select mobiles here. Understand? This path also we need high availability, right? This path also mobiles may be traffic more. Again, we need to create multiples mobiles path. That's what I have created here. Multiple servers for electronics. It will may increase, it will may decrease, depends on the load on that particular application. Is this clear? But entire load, how we can get high availability? It's an instance level. I mean here, see what I'm going to do. This is each instance. So to provide high availability, we need to create multiple servers and configure with the ELB to give the access. And auto scaling will work. Or you tell me guys, how many auto scalings are required? 1 or 50? Hmm? Auto scaling create from where? Hmm? Template. Template will create from where? Okay. How auto scaling will create same application? Image. Image from where is going to create image? EC2 instance. Leave it for Docker at this time. EC2 instance. That EC2 instance having multiple applications or only one application? Hmm? Only one application. So image coming from server. Auto scaling are giving source for image. So auto scaling will support only same image, right? So 50 applications we need to create 50 auto scalings. Clear, right? Okay. See here. But what client is saying, need to develop this project with minimal budget. But is it minimal budget? 50 auto scalings, 50 load balancers, 100 servers. 100 servers. If something is issue is there, to find out the issue, which server also it will take 1 hour time. Understood or not? Then how you can say it is a high availability architecture? No, this is not high available architecture. High available architecture is not only provide high availability. If something is wrong, we need to rectify the issue in a seconds. But to understand where the mistake is, to find out, it will take 1 hour. So what you are doing here, you are making your architecture is difficult. First of all, making process is very difficult. Then making process is very difficult. Mean find out the something in that architecture is very difficult. Costing increase. So it is not a reliability. It is not a high availability. So this is supports for only single application kind of that. That is a monolithic approach. Already yesterday we done. Clear now? So multiple applications, if you're trying to do in by EC2 servers, we need a multiple servers. So now, can we do it this process in simple way? That is Docker. So Docker, instead of maintaining 50 applications in different servers, I can split it into multiple applications in the form of containers. We can host 50 applications in only one EC2 instance. Is this clear? Same architecture I will draw in the Docker. You can understand. Let's go to the Docker. Okay. Same architecture. Now this is only one EC2 instance, not 100 EC2 instances. Understand? Okay. with Docker. Okay. Same process with Docker. Is this clear? Same process with Docker. Okay. Now 50 applications, right? 50 applications. 50 applications. Okay. Okay. So this is the EC2 instance, right? So if you install Docker, okay, if you install Docker here, if you install Docker, you can split into 50 application in your one EC2 instance by making containers process. So now, okay, this is container one. Okay, okay, this is container one. So inside fashion, okay, fashion container. So this is fashion container. So if you need high availability for the fashion container, we need one more fashion container. Is this clear? If you need high availability for the fashion container, we need one more fashion container. Okay, leave it. Is this clear? Same. If I need high availability for electronics, first we need to create a first electronics container one. Okay. So to understand, to get high availability, we need one more electronics container. Okay. So again, if I need one more container, so you can write sports and all. Okay. So finally, it is working on one server only, one EC2 instance only. But how containers will create from the Docker is creating the containers. It is coming from images. Already we discussed. Anyway, we are going to discuss one more time. So here, like this, we are going to create a multiple containers. So let's example, you can understand like this. So I can't write all applications. So you can understand this is different applications. Okay. So these many containers are running. Is this clear, guys? Okay, Docker is creating containers in the one EC2 instance. That is very clear. This is one EC2 instance I have installed in the Docker. So I have installed in the EC2 instance in the Docker. So now my Docker is running. So Docker is creating containers. So now here, what are the challenges we face in this block? One is auto scaling, one is load balancer. Two things we face the issue, right? 50 load balancers, 50 auto scalings. So whenever Docker is created a containers, the Docker job got done. So Docker Swarm something process is there, but we are not using that. It's going to deprecate. So Kubernetes is taking care of everything. So leave it. Just creation of Docker image, Docker container only we are going to discuss. Then we jump to Kubernetes since we are not using anywhere in the industry Docker Swarm. Docker Swarm, Kubernetes both are equal, but Kubernetes is very advanced service. Docker Swarm is not work in that level. So that's what Docker will use to create a container only, not for REST process. High availability will not achieve from the Docker in that level. So high availability will get achieved from the Kubernetes. So Docker plus Kubernetes entire process is a microservices. So now 50 applications are there here on running in one EC2 instance. So whenever fashion container will create, one container will create. But how 3 containers will increase, 4 containers will increase, 5 containers will increase, that is taken care by Kubernetes. Here two high availabilities we need to understand. Containers high availability. Container high availability. Containers level. High availability taken care by Kubernetes. K8s. Just understand. Kubernetes are K8s, both are same. Okay. So now containers availability taking care by K8s, right? If it is a EC2 instance, we need to create a auto scaling group to increase the servers. But in this Kubernetes, there is a self-healing process. Self-healing means Kubernetes, the backend, it will create a servers. I mean, containers automatically. That is called self-healing process. That is a Kubernetes itself, it's coming that. There is a controller concept in the Kubernetes. So the Kubernetes is a managed service. Few things, a self-healing managed service. When I say self-healing managed service means Kubernetes is able to increase the containers, decrease the containers, system itself. Not required in auto scaling group in this. That is Kubernetes inside itself service. It's taking care of Kubernetes providers. That is called self-healing. So how containers will increase, containers will decrease, the process of self-healing. Okay. Now, these are all containers running on how many instances? One instance. If node may fail, all containers will fail, right? That's what Kubernetes will provide high availability in the node level also. Node level means we can create multiple nodes with the same pods. Same you can understand, guys. Two EC2s running on same application, different availability zone, different region to get a high availability, right? Same thing here also. So same copies here also will come. Okay, same. Same containers will run. So for example, if I say to your Kubernetes, fashion, I need a 3 containers, maybe it will schedule 2 in this first node, 1 in that second node. Understand? But 3 are same applications, right? So service will get the information, take the response from the client and redirecting into the either node 1 or node 2. So in the Kubernetes, we have a different concepts. Node schedules concept means on pod which node it is going to schedule. That is a separate process. In Kubernetes, we are going to learn how to achieve container high availability, how to achieve node high availability. And I mean, you need to understand, guys, if you go with Kubernetes, we need to call as a pods, not a containers. Okay. Once again, I'm saying if you run image by using Docker, container will create. If you run same image by using Kubernetes, pod will create. If I run Docker image by using Docker run command, container will create. If I run same image by using kubectl apply command, Kubernetes apply command, container will create on top of the one more layer will create, that is pod, since it is created by Kubernetes. Understand the difference? Okay. See here. There is a image. Okay, let me explain here. Image. Okay, before that, one more topic is pending here. Self-healing, we got it, right? Now, how to give access this 333 all right? See, each container one IP will create, network will create. To give access, you can give your node IP and port number. So here, if you want to give access, this is the node IP, right? EC2 instance IP and follow by this port number. We can give the access. Understand? How to give access? For example, this is 192.168.1.2. This is EC2 instance IP, right? If I want to give this container, which container access you are going to give? That you need to decide and enable some port number. For example, this fashion, I have enabled the port number is 80. And the electronics I have enabled is something different 3000. How to access fashion electronics means you need to access 192.168.1.2 80. Sorry, colon 80. The request will go to fashion. If it is go to electronics 192.168.1.2.2, same IP, right? It will not change. Node IP is only one. 3000. Understand? So 3000, the request will go to electronic. If you are accessing through node port, sorry, node IP following by port, but we are not using like this process, right? We are using what? Load balance. Understand? So we need to create a load balancer. Who will create this load balancer? Kubernetes will create now. Why? We are giving enter access to Kubernetes. Kubernetes will create a load balancer and it will all containers. This is path-based load balancer or not? Definitely path-based load balancer. In Kubernetes, there is a concept ingress controller. Kubernetes will create this load balancer through ingress controller. This ingress will create a load balancer, path-based load balancer. Is it clear? So Kubernetes will provide access to outside. And before that, Kubernetes will create multiple containers through self-healing process. Is this clear, everyone? Yeah. So what are the challenges we face here? Creation of multiple load balancers, creation of multiple auto-scaling groups. Even though we need to understand here, one application in one needs to write, but you are not using entire configurations of the server. Specifications of the server. Maybe you are using 2%, 3%, or 10% max. Remaining 90% is going to waste or not. You need to pay, right? But here, you can create containers till support your hardware. Understand? Why? It is running on only one EC2 instance by sharing the memory from the hardware of your EC2 machine. Until support your hardware from the node, you can create multiple containers. For example, your EC2 instance is 10 GB. 10 GB hardware, your EC2 instance. You can create containers till complete 10 GB hardware. Understand now? So since Docker is giving the containers very lightweight, as we discussed, the image and all is very lightweight, so that you can create multiple containers. Sir, if 10 GB hardware means we can create one container, na, sir, each image contains 6 GB, 5 GB, na, sir, each Linux. No, that is in Linux virtualization concept, but Docker will give only very, very lightweight image without any dependencies, without any default dependencies. If you go and create one EC2 instance in the Linux, it will give so many dependencies, Python, Java, whatever, Tomcat, Maven and all, but not required. This application will run on Python. You need only Python dependencies. In that case, you can take a basic empty OS. You can install Python image. That's it only. No need to take default OS like a AMI. Understand? Yeah. So AMI means what? OS of EC2, right? With the default dependencies. With the default dependencies. Is this clear? So that Docker has installed on that. Docker is running. Light. Now the process is what I'm trying to say now here. We are not recording any AMS. We record only Docker images. We are not recording any Amazon Mission images. We record only Docker images. The process will start from the Docker image, not from AMI. Understand now? If the AWS, if you need multiple instances, the process will start from AMI. Selection of AMI, selection of network, and create server. Now process will start from not AMI. The process is start from Docker image. Instead of AMI, we are using Docker image. Understand? Simple thing. AMI contains OS plus default dependencies. Is this clear? But Docker image contains only OS, no dependencies, only OS. Plus, we can add required dependencies. When I say only OS, to say that this is Ubuntu, this is Red Hat, the required dependency only there. The required dependency is very, very lightweight, like MBs only. So in this case, I can say this is 100 MB. In this case, I can say this is minimum 8 GB, minimum 8 GB just. Is this clear the difference now? So you need AMI of Ubuntu. You need AMI of Amazon Linux. I need Docker image of Ubuntu. I need Docker image of AMI Linux instance. If you go with Docker image of Ubuntu 100 MB, if you go with AMI Ubuntu, it is 8 GB. You know the difference, no? So finally, we need Ubuntu only. Finally, we need Red Hat only. Finally, we need CentOS only. Means this application will fit to that OS. Then take the only base image, not for dependencies. Why? So your application is to run only Python application. Why Java dependencies? Why Maven dependencies? Why we need to run the backend all dependencies? Take a one base image and add your Python dependencies. Run your application. Python application will run on base of Python dependencies only, not Java dependencies, right? Since you know this application is Python, then you can add Python dependencies. That's it. So let's an example. My Python. This is my laptop. In this my laptop, I have a one Python code. I have one Python code. So to run Python code, what I need to do? Do I need to purchase one more laptop? No, what I need to do? I need to install Python only to run Python application. To support OS, I have a laptop. Same thing, you have a Python application. You have a Python application. You need what? OS and Python dependencies. That OS only to support Python dependencies is enough. So do I need to install Java to run this? No. Same thing, you know the application, right? Python application before. Then take a base OS and install Python dependencies to run a Python code. That's it. Clear now? Sorry, chart everyone I have enabled now. Kubernetes will work both levels, node level, pod level. Node level to give a high availability, pod level to give a high availability. Okay, I'll come to that. Just wait. Till here clear? Okay, how the process will start and where it is end, we can discuss now. The first process, okay, Docker image OS plus dependency you have added, right? Okay, this is first the process will start. Same thing, I think already explained, right? Let's go with one more paint here. Workflow. Okay, workflow both Kubernetes and Docker. Okay, tell me guys, same Uber giving project, right? So developers develop the Python code. Okay, developers develop the Python code. Push it into GitHub, right? Push it into GitHub. If you know the process, what you need to do, that's enough for DevOps. You know what you need to do first. How to do it, so many references we have. If you know what you need to do, you can search in Google, you can take the references. You know what you don't know what you need to do, what you can search in the chat GPT also, Google also, right? Understand? Chat GPT will give based on your search key. To search something, first you need to understand what you need to search. Is that clear? To understand that, these classes are very important. We can go in that labs also, but I'm saying that. Okay. They will send this code, push this code into the Docker Hub. For example, this application is fashion application. So developers push the developer the fashion application and push it into GitHub. Now your fashion application there in your GitHub, right? GitHub. So what is your agenda? You need to take this fashion application to host in your, let's come now, host it into one server. This is monolithic approach that already we done, right? Take it into, deploy into one EC2 server. To add some dependencies by using Maven or other thing, whatever it is, we can add and we can host it into server. Host it into server. Okay. Yes, this application added some dependencies and you can host it into one EC2 server and you can give access to public by using ELB, right? By using ELB. Okay. Your public has access to your application, but you need to do implement for this 50 applications also, right? So now, okay, this server create from where? AMI image, right? AMI, for example, Ubuntu, AMI Ubuntu. Is this clear? So in your server is Ubuntu server created from AMI image, Amazon machine image. Why AMI required here? Why AMI required? What is AMI? Amazon mission image. Which OS we need? Ubuntu. Why Ubuntu required? To run your application, Ubuntu OS is required in the server. So you have taken Ubuntu server. So you have already Python dependencies inside. The server itself it will get. If not, we can install it. Now it run this server and give the access to ELB. This is clear? So this is the Python code. To run, you have taken AMI, Ubuntu, create a server. Server is there, Python code is there. If there is any dependencies, you can run directly. Otherwise, add. What I need to add here? What I need to add? Python dependencies, right? If not there, add Python dependencies. But so many dependencies are there. Not only Python dependencies. Is this clear? Your code is there. To run that code, we need a server. Server created from AMI. That is AMI Linux Ubuntu image. To run this code, this is a Python code. So Python dependencies I have added. Now both are, we have all requirements. Now it is running. We are giving access to public. That is fashion. This is Python. Anyone has any doubt here? So here we did. So what are the actions here? First, create a server. So leave it for code. That is taken care by developers, not us. Code is ready. That is Python code. Developers are saying this is Python code. To run this code, we need a server. We need some Python dependencies. We can add it and run it. So to need a server, that's what we are taking from directly AMI. We are created, we have hosted and running, and it is working fine. But in the same process, if I go with Docker, what I need to do, guys? Here the process will separate, right? So what I need to do? Here you are taking what? AMI from the Ubuntu. Here what I need to take? Ubuntu from Docker. Clear? The difference here? Here we need to take Ubuntu from Docker Hub. Is this clear? Now image, Ubuntu image. But here AMI image. Understand the difference? AMI image, Ubuntu image. Ubuntu image comes from Docker. AMI image comes from AWS. So your Ubuntu image is there from the Docker. You have taken that. Now what you need to do? Same thing. Compare with this process only. Whenever you create an instance, a server, we have added Python dependence to run a Python code, right? So now here your Ubuntu image is ready, like a AMI image. Next, what you need to do? Add Python dependencies and run it, right? Okay. Next, what you need to do? Run. So add dependencies, Python dependencies. And add Python dependencies. If your Python dependencies is ready, your Ubuntu server is ready. I mean, Ubuntu OS is ready. Next, what we need to do? In this EC2 server, there is a hardware, right? To run that hardware, it will give server itself. Application there in EC2 instance. To run that hardware, RAM and all, it will take from the same EC2 instance. Is this clear? But here, take from host mission, where the Docker is hosted, either VM or EC2 or VM, Azure VM, GCP VM, whatever it is. Understand? OS will not take from host mission. OS we already taking from Ubuntu, right? Is this clear till here? Okay, so your hardware also there to run your application, and your OS is there, dependencies is there. Now you copy source code and run the image, right? So if I run the image, what will be create? Hmm? Container will create. Run. Image run means container will create. Inside container, what it will be there? Okay, inside EC2, what it will be there here? Hmm? Okay, code and dependencies. Here again, inside container, code, dependencies. Code you need to copy, right? Clear? Is there a difference here to here now? Is there any difference here to here now? Hmm? Your container also run as a server, right? EC2 server. We have a code, we have a dependencies, we have a OS of Ubuntu. Okay, let me write OS also. Which OS it is? Ubuntu. Hardware will take from host machine. So now you can give access. So container is created. Now you can give access to ELBR node port process. I'm not explaining any Kubernetes now, just explaining Docker process only. You need to understand here. So Docker, you can give with the access to public. Is this clear? This is called what? Container. Clear? This entire process we can call Dockerization. That is Docker file. In the Docker file, we need to take Ubuntu and add dependencies, run, create a image. From the image, we can create a container. Whenever Docker file we can build, image will create, run that image, container will create. Okay. Where is the EC2 secondary pro? That is host mission. You can install Docker and any EC2 only, right? It is running on one EC2 instance. That's what I have mentioned. Host mission here. Host mission may be EC2 instance. Clear everyone? What happened? You join now only, Nasham? I'm keep on explaining from 35 minutes, same process. Okay. Anyway, Docker flow, this is high level, right? I'm going to explain on very low level. Then what is your confusion here? Whatever box sector you can make it here for your understanding. Okay. Anyway, for you, I will give a one big box. This is enter run on one EC2. Now clear. But you need to understand if I draw one EC2 here. The problem is, may you can understand every container one EC2 will come. That's what I'm not drawing here. Understand? Anyway, let's come now for low level workflow. Please concentrate everyone. This is very important. Docker Hub. Okay, the same requirement. One more time, I'm explain. You have a source code. You have a source code in GitHub, right? This source code in GitHub, pushed by developers. So first we need to understand here. Docker process one I'm explaining here. Okay. Source code is ready. This is Python source code. Already developers discuss with this is a Python source code. Means we need to add a Python dependencies. Is this clear? For that, first we need a server. Server in the form of image Ubuntu or any flavor. So we are explaining in a Docker process, right? In the Docker process, we need what first? OS. I mean here what we need first? Server. To host this Python code, we need a server. The server OS will come from where? AMI, if it is a AWS. But I'm not going with that virtualization concept process. I'm going with the Dockerization process. The Dockerization process, I will take the images from the Docker Hub only, right? So I'm preparing a server now. I'm preparing a server now. Same here, you are preparing server for 7 steps, right? I'm preparing here server now to host my application. Okay. In that server, I need dependencies also, right? In the form of preparing server, I need to add the dependencies. I will take this sample OS. I will copy the code. I will run the code. Is this clear? No? Same like EC2 instance. So now I need first what? Okay, let's take here one. Okay, I need first what? Your source code is ready. First, what you need now? OS. Yes, you are correct. OS. OS. Let's take an example, Ubuntu OS. It will come in the form of image only. Is this clear? Comes from where? Docker Hub. Is this clear? Your OS is ready right now. Your OS is ready. Next, what you need? You need to add dependencies. Is this clear, everyone? Okay. Let's now again removing this. Again, I'm adding. You need what first? OS. Take that Ubuntu OS image. Image. This is Ubuntu OS only. Next, what you need? You need to copy the source code, right? You need to copy the source code here. Okay. Next, what you need to do? Source code is ready. Ubuntu is ready. Next, what you need to do? What you need to do next? Add dependencies. Is this clear, everyone? No. So plus. So if you can see here, guys, Ubuntu image plus source code plus dependencies. Now your requirement done, right? To run your source code, we have a Ubuntu OS. To run your source code, we have a Python dependency. Since it is a Python, we have added Python dependencies. Okay. We have added Python dependencies. This source code is Python source code. Is this clear? We have a Ubuntu image. OS we have, source code we have a dependencies. What you need next? What you need next to run this? Hardware, right or not? It will take from where? Host was means EC2. Is this clear? Now, if I want to create one more container, second container also will share hardware from host machine only. I mean, here 3 containers we created, maybe different applications or same application, runs on same EC2 instance or not. Is this clear now, everyone? In this, if it is a EC2 instance, EC2 hardware is there, AMI OS is there, we copied the code, we added the dependency. Is there any difference of process now? Here to here, is there any difference process now? No, right? Same process. But here, unnecessary dependencies are there. Here, only required Python dependencies are only there. If it is a Java code, we can add only Java dependencies. So that we are trying to minimize the process, the space and all. Clear? So this, it will take maybe 120 MB only or 100 MB. This entire process maybe take 100 MB. So here also 100 MB. Here also 100 MB. Understand now? Like that till we can create to support your hardware. Space talks about hardware only, right? For example, this is 10 GB hardware. I can create multiple containers. Is this clear now? Yeah. So the first, this is entire process is, we are doing this entire process is Docker file. In the Docker file, we can make it this all 3 steps and run a image and container will create. Is this clear everyone? Yes. Can we host that? Yes, we can host database also. Everything we can take. What will be the usual storage capacity of single container? Depends on your dependencies, right? If you add multiple dependencies, it will take. So base image store is 60 MB, 50 MB. Base image. It's close to 100 MB only. Any image if you can take close to 100 MB if there is no dependencies. Is this clear? Okay, guys, you tell me one thing. Instead of taking Ubuntu image, can I take Python image directly? Understand? Python image also there. Can I take Python image? What is the size of Python image? Which one is the more size, Python image or Ubuntu image? Python image. Since it is there, already dependencies are already, right? Understand? What I'm saying, Ubuntu image, Python source code. Combine these two, we can create one more image, right? That image contains what? Ubuntu OS plus Python dependencies. If I take directly Python image means definitely it will run on one OS, right? So the size will be more, right? OS plus dependencies. If you take only Ubuntu is there is no dependencies. Understand the difference here. But if you can take understand here also difference. If you can take a Python image directly, somewhere the Python is running on some OS. That OS you are unable to see. You are taking ready-made Python image. Means Docker developers, Docker providers, they are already taken some OS and running the Python image on that image, create one final Python image giving to you. They are giving directly Python image, but the backend they have followed the process, already taking one Ubuntu and install Python and giving image to you. Means that image is running already in some OS. That is you are unable to see. That is Docker is taking care. No, if you not depends on the ready-made process, you can take a process from scratch, take one Ubuntu image, install dependencies and all. You can create a one image. Understand the process now here and there? Yeah. Any questions now? Yes, we can take, I think Sharma, right? Question is asked. Yeah, Sharma. We can take directly Python, sorry, MySQL images. See here. But the difference we need to understand here. MySQL image is there directly. I mean, MySQL image there means what, guys? What you can understand from this? The size is 174 MB. Okay, what we can understand? It is not running on any OS. It is running. They are giving MySQL image directly. Otherwise, if you want to prepare this MySQL, take any one OS, add MySQL, prepare one image. That image contains OS plus MySQL. But this image contains MySQL in my end. But the backend, this OS is running. Any questions? Yeah, I'm coming that. Wait, I'm coming that, Harshal. Does this? Yes, Docker is open source. Depends on your project. If it is a Java, you can add Maven. If it is a Node.js, we can add NPM. Different projects, different. But closely, we are 90% projects on Java only, front end and so that's what we discuss Maven only. Yeah, we can keep. See, if you not maintain your image in Docker, how you can call your custom applications? This is for existing applications. Now understand, Kiran Kumar. So your requirement is to create a table in MySQL. Your requirement is to create a table in MySQL. Your manager is say that create some sample table in MySQL. You have so many ways. In your laptop, install MySQL, create a table. Since your laptop work as a server, install MySQL, create a table. Don't use laptop means go with cloud. Create one EC2 instance. Install MySQL, connect MySQL, create a table. No, go with Docker concept. Okay, take one Ubuntu OS, install MySQL dependencies, create image, create container, log in the container, create a table. Or you can take directly MySQL image, run the image, container will create, log in the container, create table. Understand the differences here, everyone? Let's come to now Kubernetes process. You are again coming to same story here. Container OS will not use from host mission. Understand? We are taking OS Ubuntu image already. If there is no concept of taking Ubuntu image, you can take OS from here and copy the Python source code and Python dependencies. If you can do that, your host mission is only Python for sorry, your host mission was only for Amazon Linux. Understand? Will it run this code in Ubuntu? Why? If it is sharing OS means your EC2 server only Amazon Linux EC2, it will not run Ubuntu commands. Understand or not? If it is sharing OS also, that OS is Amazon Linux OS. So it will run only Amazon Linux M command only, not apt commands. Understand? There is no use, right? Indirectly, what depends on there is some dependencies again. You need to run only Amazon Linux applications. You need to run only if it is Ubuntu server, Ubuntu dependencies only means there is no use, right? See, hardware is common for any OS. Is this clear or not? Is there any separate hardware for Ubuntu, separate hardware for Mac, separate hardware for Windows? No. Here, common thing is hardware. That's what we are using. Hardware is a common thing. But your code will dependencies will change OS to OS to OS. Is this clear? For example, in your case, OS is sharing from the EC2 instance. It will run only what type of OS EC2 will give only that dependencies only. It will not run Ubuntu application. It will not run Mac application. It will not run Windows applications. Is this clear now? So here it is not taking any OS from the host machine. Your required OS you need to take from Docker Hub in the form of image. In the AWS in the form of AMI you are taking, right? OS. Here you can take OS in the form of Docker Hub image. Is this clear? The difference. This understanding is very, very important. Otherwise, it's very difficult to understand Docker. Very good. Yes. You just understand, guys. There is a virtualization concept, right? What is virtualization? What is virtualization, guys? Does virtualization will share any OS from the host machine? Hmm? Does virtualization any share OS from the host machine? No, right? If it is a share means, can you run Windows application on your virtual machine? No. If it is a Windows laptop, for example, Windows laptop, you have installed virtualization. It is taking OS from Windows means it will run only Windows applications, right? Not Linux applications, right? If the dependency is there, OS dependency is there, there is no use of virtualization concept, there is no use of Docker concepts. You have to stick on same OS applications. In that case, if I want to run, for example, my Docker want to run Ubuntu OS, again you need to create one more server for Ubuntu EC2 instance, right? Since your EC2 is sharing from OS from the before Docker container, it's sharing from the Docker container, that is Amazon Linux. Next container will support only Ubuntu means you need to create one more EC2 instance for Ubuntu. If it is a sharing like that. If it is a Mac application, you need to create one more Mac EC2 instance. If it is a Windows, you need to create like that. You are increasing EC2 instance again. There is no use for Docker again. Docker will support. Docker will not depend on any OS from the host machine. Only hardware. Is this clear now? But many YouTubers are saying take from the host OS. That is not correct. If it is correct means it will support only that kind of applications only, not for other applications. Exactly. We are installing Linux, Ubuntu, Red Hat depends on your requirement by taking image. Now, if you want to run a Java project, we need to install dependencies of Java. That's it. Understand now? Yeah. Same guys, don't confuse here. So you can understand this is AMI otherwise. This is AMI. Ubuntu image means AMI image. You can understand. Is there any difference? AMI image, Ubuntu image, only difference is dependencies. That's it only. If you take AMI image, many dependencies will come. If you take Ubuntu image, only Ubuntu image will come. That is the difference only. Why can't we take directly AMI image and create a Python source code and dependencies? If you take, the size will be more, but we need to decrease the architecture and size and all, right? Yeah. Yeah, it is isolated. Yeah, usually we can deploy only one image in one container, Nagarjuna. Let's come now. We have only 4 minutes time. So let's come now. Okay. So taking image. So now how Docker will run? If your image is there, right? Your image is there. Just a minute, guys. Hello? Just tell me. Okay. If you can take a Docker image. Okay. In the Docker process, if you want to create a container, you need to run the image. Understand? Create a Docker container. Create a Docker container. We need to run what? Containers will create after run the image only. Is this clear now? Image comes from where? Docker Hub. If it is a custom means you need to add dependencies, create custom image. So default image, or custom image, whatever it is. Custom image comes from where? Very good. Custom images comes from Docker file, since we have added everything. Finally, custom image is ready, or Docker, whatever, default image is ready. We need to run, create a container. Is this clear, everyone? By using Docker run. If you use Docker run, containers will create, not pods. Is this clear, everyone? No? Now this is called container, not pod. If the same image, if you apply Kubernetes kubectl command, kubectl apply command, it will create pod. Understand the difference now? The image is common for Docker. If you run Docker, image is common. If you run Kubernetes, image is common. So where you need to go with? If you are going with Kubernetes process, it will create pod. But what we can understand, sir, if Kubernetes run pod, there is no use of Docker, right? Then why Docker? To build image Docker required, right? To build image Docker file required, right? Yeah, Docker file we can use for to build image only. But one more very important point we need to understand here. Inside container will come. Understand, here to here difference is what? Only one more layer is added. That is pod layer if you run by using kubectl. Understand the difference? So Kubernetes, there is no any container platform. Kubernetes will take Docker platform to run your image. Understand? Kubernetes apply means it will take help of Docker to run a container. On top of the container, it will apply pod layer. Understand? Sir, inside pod container is there, right? Who will create container? Docker only create container, but Kubernetes will say to Docker to create a container. If Kubernetes will say to create a container means it will create pod layer on top of that. If there is no Kubernetes, if you run only Docker and only container will create. If you run Docker run with Kubernetes, it will create pod layer. But we no need to run Docker run command. Just directly kubectl apply command. It will create a container. On top of that pod layer will create. Why pods? If you want to give access for entire containers in the Kubernetes, we need to install layer of pod. That layer will come once you run the command by kubectl apply. I mean here, we are run the image by using Docker. We are run the image by using Kubernetes. Understand? If you run image by using Kubernetes, pods will create. If you run image by using Docker, containers will create. Understand the difference now? Yeah. Any doubts? Others? So now you can understand these are pods, not containers. If I run through Kubernetes, but real time you are using Kubernetes only, not Docker. Docker will run backend support for Kubernetes to run container to create Docker images only. So without Docker, Kubernetes will work? No, Kubernetes don't have any runtime like a container. Yes, that's what I'm saying. Docker, without Docker, Kubernetes will not work. Kubernetes don't have any container runtime. Okay. Pod equal to container, yes. But one more additional layer is there on top of that. That additional layer is pod. But inside container, see, you need to understand one thing here. Nothing is there here. This container take and insert into pod. Understand? Since if you're running kubectl apply. If you're not running Kubernetes means there is no Kubernetes. Running Docker run only. Clear, everyone? So Kubernetes architecture will spend one day time, one class. In that you can easily understand how Kubernetes will run Docker container and all. But this is very high level what and all. Pod equal to containers. Yeah. We have one more layer on top of. Is this clear? Everyone? Any questions from anyone? So from tomorrow, exactly. I'll take this. Yeah. What? Harshal, why we are not follow same approach for monolith? That's what we discussed, right? We need to create multiple architectures, load balancer and auto scaling and all, right? Now Kubernetes is taking care of everything. No need to do. So Kubernetes will create a pods. Kubernetes will maintain the pods by using self-healing concept. Kubernetes will create load balancers, everything that is taken care by Kubernetes. There is a YAML files you have to take care. But we not Docker run, right, sir? When we run kubectl command, so we will create container. See, Docker run container. You are saying install Docker first, create some Docker file or image. Docker run command, it will run, create a container, right? Now, if you want to create a pods, but finally pods only, we are giving access, not containers. What you need to do? Same server, we need to install Kubernetes. And Kubernetes will say to Docker run, not you. If you run, container will create. If Kubernetes will say to create a Docker run, pod will create. Understand? Here superior is Kubernetes. Hey Docker, you can run container and add my pod layer. Is this clear now? If there is no Kubernetes, if you run Docker run, only container will create. Okay, guys, that's all for a very high level understanding of Docker and Kubernetes. Even I needed so many points. We don't have much time to add it. Even coming classes, we can clear those doubt. But first, we need to create a Docker, install Docker in your EC2 instance. Why EC2 instance? We need one host machine to create, right? Then we can start our work. Is this clear? Yeah, without Docker, Kubernetes cannot create container. That's very clear. We have a class tomorrow. So I think next week there is a holidays, right? That's what we are taking class for tomorrow. Okay, don't miss the class. Even try to attend online also. If you're unable to come, is there any festival mood or all? But if you miss first class, very difficult to understand 6 classes in Docker. That is very clear. Bye, guys. We are running out of time. Thank you so much for your support. We'll meet tomorrow. Bye bye.